Okay, students, so today we're discussing electron configuration. There are three things you need to consider. These are the three things that an electron wants to do. First of all, an electron wants to stay close to the positive nucleus. We know that the electron is negative, the nucleus is positive, so opposites attract.
Yeah.
So remember, number one is opposites attract. The second thing is electrons want to stay as far as possible away from each other because light repels light, right? So light repels light. And lastly, electrons are lazy. They want to carry as little as possible in energy, so they have the smallest amount of energy. They want to be lazy. Okay, which leads us to the next principle. This is Heisenberg's uncertainty principle. Heisenberg was a German scientist, and he said, you can only know one thing about the electron. You can either know the speed or the velocity, or you can know the location, but you can't do both. So his uncertainty principle or exclusion principle says you cannot know both the speed and the location of an electron at any given point in time. You can only know either the speed or the location. All right, the next thing I want to focus on are electron configurations. Thank you. So this is where you guys come in. This is what we will learn today. Each electron has their configuration because each atom has their electron configuration because each atom differs from a different type of atom, of a different element, like a fingerprint differs from person to person. So electron configuration explains the arrangement of each electron in the atom. And we use this. S, P, D, and F. So those are the four letters you will remember. S, P, D, F. Okay? Let me give you an example. An example would be let's say we talk about nitrogen. Can somebody tell me the symbol of nitrogen? N, right? And N has 7 protons and 7 electrons. Today we are focusing on the electrons. So 7. So I will have 1s2, 2s2, 2p3. Okay, we'll learn the details in a little bit, but the 1, the 2, and the 2, those are electron levels. Right here, energy levels. So these right here are your energy levels for the electrons. And up top here, the small number, those are the actual electrons. Okay, so I have 2 electrons floating in S, 2 electrons floating in 2s, and 3 electrons floating in 2p. And then S, P are sublevels. So S and P, can you see me okay? S and P, all of these actually, are the sublevels. Are you with me so far? Mm-hmm. It's a new concept, I understand. It will make sense in just a little bit. The next thing I'd like to introduce is the principal energy level. The principal energy level, or PEL, describes the space. So the electrons occupy the space surrounding the nucleus in principal energy levels. A principal energy level is also called a period. and most scientists will relate to this period, which are the numbered rows on the periodic table. So they look like this: 1, 2, 3, 4, 5, 6, and 7. Do you see them up here on the table, on the board,
Yeah.
on the wall here, right? 1, 2, 3, 4, 5, 6, 7. These right here define your S. This block right here is your P. Then this is your D, and this is your F block. Right, you can stop.